Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, imagine an AI not just answering questions, but actually doing research, forming hypotheses, writing code, debugging, and improving itself step by step. This is exactly what the paper AI Scientist via Synthetic Task Scaling by Ziyang and Harkirat Behl explores. So here's the problem. Current AI agents look smart, but often fail in real research workflows. They generate ideas, but those ideas don't always work. Why? Because they lack experience, not knowledge. Most models are trained on final outputs, like papers or code, but real research is messy. It involves debugging, failed experiments, iteration. This paper flips the approach. Instead of just learning from results, it teaches AI by letting it do the process. The core idea is surprisingly elegant. Create a massive number of synthetic machine learning tasks, then let a powerful teacher model solve them, and use those solution trajectories to train smaller models. Think of it like training a scientist, not by giving them textbooks, but by making them solve hundreds of real problems. The pipeline has three main stages. First, task generation. The system automatically samples ML topics like computer vision or graph learning, then proposes datasets validated using Hugging Face APIs and generates full code environments, including starter code. Second, verification. Tasks are not trusted immediately. They are run inside an environment, and if something breaks, there's a self-debugging loop. The system fixes errors iteratively instead of discarding tasks. Third, trajectory generation. A teacher model like GPT-5 solves these tasks, producing step-by-step reasoning, code edits, and actions. Now, here's where it gets powerful. Each task produces multiple trajectories, and each trajectory is like a story of problem solving. These include trying ideas, editing code, running experiments, and improving scores over time. The system generates around 500 tasks and tens of thousands of trajectories, but not all trajectories are useful. So they apply filtering. Only trajectories with at least one successful result are kept, and very long ones are truncated to keep training efficient. Then comes training. They fine-tune smaller models like Qwen 34B and Qwen 38B using these trajectories as supervised data. And the results? Pretty significant. Performance improves across most tasks. In MLGym, a benchmark for ML agents, specifically AUP scores increased by 9% and 12% respectively. That's not just marginal. It shows that experience-based learning works, but it's not perfect. There are some important pitfalls. First, task coverage. Some complex tasks like MS COCO don't improve much. Why? Because the synthetic tasks don't fully match real-world complexity. Second, bias from the teacher model. If GPT-5 can't solve a task, that knowledge never enters the dataset. Third, evaluation limitations. Everything is tested on MLGym, so generalization to other environments is still uncertain. A practical tip here: if you're building agent training systems, don't just scale data, scale diversity of environments and failure cases. Another interesting insight: this approach can extend beyond supervised learning. The same setup could be used for reinforcement learning, where the reward is the final task score. But there is a challenge. Training involves long GPU runs, and rewards can vary widely across tasks. Still, it opens a path toward truly autonomous AI researchers. So the big takeaway: to build AI scientists, we don't just need smarter models, we need better experiences. And this paper shows how to scale that experience synthetically. What happens when these agents start discovering ideas we haven't even thought of? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.